What up, what up? If you are watching this, you are beginning Unit 1 of AP Precalculus. We're going to go through these 4 sections, so let's learn a few things and let's practice a few problems and see how long this takes. Probably about an hour, give or take. This is a periodic function. A periodic function is basically something that repeats a cycle over a certain amount of time. Now, when you're looking at a periodic function, just from a graphical point of view, you're looking at a few things. You are looking at, for A, its period, which means how long does it take to complete a cycle? Okay, so the period is basically going to be the distance from this x value to that x value. Another thing that we'll care about is the amplitude. The amplitude is not the very tippy top to the very bottom, but the very tippy top minus the very bottom, which gives you the total distance, but divide that by 2. So the amplitude is going to be half the distance from the top to the bottom, whatever that distance is. Periodic functions repeat themselves. So a lot of problems are going to be like, hey, look at this guy, but give me an answer of something down the road in part of the graph that you can't see. We'll deal with that when we have to deal with that. That's a periodic function. Okay, the most basic kinds of periodic functions are sine and cosine. Now, before we get into anything different, let's look at the most basic version of sine and cosine that you may have learned back in the day. You probably remember SOHCAHTOA. And what SOHCAHTOA meant back then was sine of an angle meant its opposite over its hypotenuse, and the part of SOHCAHTOA meant the cosine of an angle equals the adjacent side over the hypotenuse. Now, when we look at this picture right here, the sine of my angle is going to equal the opposite over r. We're going to look at sine in 2 different ways, and we're going to look at cosine in 2 different ways. Way number 1 is, what if you're dealing with something called the unit circle? What if you're dealing with the unit circle? The unit circle is when r is equal to 1. Otherwise, we'll deal with everything else. So the old EE, everything else. Now, when you have the unit circle and r is equal to 1, sine of theta is going to equal y, its opposite side, over its hypotenuse r. So sine theta equals y over r, which is y over 1, which is y. So sine theta is just the y value. Oh, well, how nice. I wonder if cosine will give us something similar. I don't know. Let's get a different color and find out. Cosine is the adjacent side over the hypotenuse. So cos theta is going to equal the adjacent side, which is x, over the hypotenuse, which is r. But r is 1. So x over 1 is x. So cosine theta is equal to just the x value. So good news. If I give you the unit circle and you know r is equal to 1, you have an x and a y value of cos x or cos theta sine theta. Your x value is cos theta and your y value is sine theta. Oh, how nice. Well, what about these everything else problems that we were talking about over here, where r is just some number that we don't know about? Well, if r is just some number we don't know about, then sine theta is just going to equal y over r. If I want to kind of recreate this guy over here and I multiply r to both sides, that gives me r sine theta equals y. Oh. And as we probably are going to figure out, if r sine theta equals y, I could do the same thing with cos theta. Cos theta is going to be x over r. And if I multiply both sides by r, then r cos theta is my x value. So when I give you problems where the radius is not 1, I could use this point here. So very often, we will be given problems that have to do with coordinates. Sometimes the radius is 1, sometimes it's not. And if the radius is 1, we will refer to the x as our cos theta, the y as our sine theta. And if the r is not 1, then we will refer to the x coordinate as r cos theta and the y coordinate as r sine theta. So that's basically the basic definition of what sine and cosine means from a circular, triangular point of view. Now, speaking of unit circle, there she is. Probably the most important thing that you could possibly learn in pre-calculus is the unit circle. Let's start off very basic. The unit circle assumes that r is 1. Thank you, Jesus. Now, if r is 1, that gives us the point right here of 1, 0. That gives us the point right here of 0, 1. That gives us the point right here of negative 1, 0. And that gives us the point right here of 0, negative 1. Now, with the unit circle, we have measurements that we care about. We know that an angle is measured starting from the right and working our way counterclockwise, okay? An entire circle in radians is 2 pi. So you are 0 radians. If the whole circle is 2 pi radians, that means half the circle is regular pi. And half of half a circle is pi over 2. And 3/4 of 2 pi is going to be 3 pi over 2. Now, we also need to come up with these guys. You are 1/3 of my way to pi over 2. You are half of my way to pi over 2. And you are 2/3 of my way to pi over 2. So this angle right here, multiply 1/3 to pi over 2 gives you pi over 6. Okay, pi over 6. Multiply 1/2 to pi over 2, and you have pi over 4. And multiply 2/3 to pi over 2, and you have pi over 3. Okay? This is going to be very much the same thing. Okay, we are at pi over 2, and we're making our way to pi. So 1/3 of our way between pi over 2 to pi is 2 pi over 3. Halfway in between pi over 2 and pi is going to be 3/4 pi. And 2/3 of our way from pi over 2 to pi is going to be 5 pi over 6. Now we're at pi, and the easy way of figuring these guys out is just add pi to all 6 of them. Okay, add pi. So add 6 over 6, or add 6 over 6 to that. That gets us 7 pi over 6. Add pi to that, that's 5 pi over 4. Add 1 to that, you get 4 pi over 3. Add a whole pi to that, and you get, what is that, 5 pi over 3. Okay, add 4 pi over 4 to that, you get 7 pi over 4. And add 6 pi over 6 to this, and you get 11 pi over 6. All right, so there's our angle measures. Probably my least favorite part. Okay, now the rest of it is coming up with the actual coordinates. Now, when we deal with coordinates, we always think of it like this way. Think of it as the square root of something over 2. The square root of something over 2. Starting from the x-axis and working your way up, you're going to start with 3. So root 3 over 2, root 2 over 2, root 1 over 2, and that's going to be your x value. So this is going to be root 3 over 2. This is going to be root 2 over 2. And this is going to be root 1 over 2. But the square root of 1 is just 1, so 1 over 2. How do I figure out the y values? Do the same thing in reverse. Root 3 over 2. Root 2 over 2. Root 1, which is 1 over 2. And now I make my way around, keeping in mind that I'm now in different quadrants, okay? These guys are basically the same exact distance and the same exact y value, so you are going to be negative 1/2 because it's a negative x value, but my y value stays the same. Okay, you line up with that. So the negative x value, because we're in quadrant 2, root 2 over 2, root 2 over 2. Okay, and now you are negative root 3 over 2, which makes sense because you're closest to the x-axis, and you are 1/2. Okay, these guys match up with those guys. Similarly, these guys match up. But now I'm in the third quadrant, which means both my x and my y are negative. So you are going to be negative root 3 over 2. The x value does not change, but the y value is now negative 1 over 2. You are basically the same as that, which is negative root 2 over 2, but also negative root 2 over 2 because we're in the third quadrant, which everything is negative. You line up with that, so negative 1/2, negative root 3 over 2. Negative root 3 over 2. Don't want to forget that. To complete this process, you guys line up with that, but now we have positive x's again, so you are 1/2 negative root 3 over 2. You are positive root 2 over 2, negative root 2 over 2. Quadrant 4 is positive negative. And you are root 3 over 2, negative 1/2. That's the unit circle. It's a mess, but it's useful. It's very useful. All right. Sine and cosine graphs. We're just going to basically draw out the very basic forms of the sine and cosine graph. Let's start out with sine. Again, everything's periodic. Sine starts out at 0, 1. Okay? Sine starts out at 0, 1, and it peaks out at regular 1, bottoms out at negative 1, and has a period of 2 pi. So it's going to start down here, it's going to peak out, and then bottom out at regular pi, which means it's going to peak out at 1/2 pi. When it comes back down here, it bottoms out at 3 pi over 2, and then comes back up and hits the x-axis again at 2 pi. Okay, so attempting to draw these is never a good idea for me, but I'm going to give it my best shot. Start out at 0, 0, peak out at 1, come back down to pi, come back down to negative 1, and then come up to 2 pi. Get what you pay for when you watch my videos. But that's what sine x looks like. That's what sine x looks like. Cosine has very, very, very similar behaviors, but this guy starts out at 0, 1. Okay, so you start out at 0, 1, and you bottom out at negative 1 eventually. But we don't bottom out yet. We start out at 0, 1. We hit the x-axis at pi over 2. We bottom out at pi. We come back out and hit the x-axis again at 3 pi over 2. And then we complete its period process at 2 pi. Okay, so drawing this guy out, we start out at 0, 1. We hit the x-axis at pi over 2. I missed it. See, now no one will ever know. Bottom out at negative 1 at pi. Hit the x-axis again at 3 pi over 2. And then repeat the process at 2 pi. So that's the difference between sine x and cosine x. Okay? So we're going to need to keep these in mind as we answer a buttload of problems that are coming our way starting now. All right. Oh, yeah. Oops. Tangent. What is tangent? We might see tangent once or twice. Tangent is literally whatever sine is divided by cosine is. That is the tangent value. You don't see tangent a ton until the second half of Unit 2, but you will probably see a teensy bit of tangent every now and then. So Tangent is just sine divided by cosine. Tangent is just sine divided by cosine. Tangent is just sine divided by cosine. Let's move my face. Now we're starting right off the bat with a periodic graph, as you can see right there. Right away, I ask you what the period is, which means if I were to pick like a spot, like right there, how long will it take me to get to the same exact spot? Well, here. So this peak occurs at 7 and then reoccurs again at 15. So if you're wondering what is the period, you do 15 minus 7, which is 8. Okay, that's the period. How long it takes to complete a cycle, and this cycle takes 8 units to do just that. What is the amplitude? Okay, well, the amplitude is the very, very, very tippy top to the very, very, very bottom, but divide that by 2. Okay, so the very tippy top is 5. The very bottom is 1. So the length from top to bottom is 5 minus 1, but you're going to divide that by 2. And 4 divided by 2, last time I checked, is 2. Now we need to plug in 41. Well, I don't have 41, but this is what I know. This is what I know. I know my period is 8. Okay, so whatever happens at 1 can be found by doing this. 8 divided by 41. Okay, or 41 technically divided by 8. That goes into it 5 times, that's 40. Remainder of 1. Now, why is that important? Your remainder is telling you that 41 behaves in the same exact way as regular 1. At regular 1, when x is regular 1, I'm at 3. So f of 1 is 3, which means f of 41 behaves the same exact way, because if I were to cut this guy and move it over a bunch of times, we will end up with that guy right there. And we can kind of see that because this ends at 20. So if I were to bump this over again and then shift it over one more, we can see that one right there. So this kind of does work out looking at it graphically if I want to look at it graphically. But that's how you find out if you can't look at it graphically. I can't extend that graph anymore because I'm out of space. I just can't do it. It's like my NASA hat. I'm out of space. Oh, man. Let's move my face again. All right. Given an interval for the measure of alpha. Ooh, what are we talking about? Me? I'm not alpha. The measure of alpha is, this whole angle right there. They want me to find sine alpha, they want me to find cos alpha, and they want me to find tan alpha. Ooh, this is the unit circle. How do I know that? Well, because the radius is 1. So if I'm using the unit circle, I can use the fact that cos, in this case alpha, is my x, sine, in this case alpha, is my y. I have a point of 0.6, negative 0.8. So my sine alpha is just my y value, and my y value is just negative 0.8. So sine alpha is just negative 0.8. Similarly, cos alpha is just my x value, and my x value is just 0.6. Now to find tangent, we do sine divided by cosine. So tangent is going to be negative 0.8 divided by 0.6. So that's the same thing as basically saying 8 over 6, which is 1.2? No, 1.3 repeating. So my tangent is going to be negative 1.3 repeating, or negative 1 1/3. Okay? So when I give you the unit circle and I ask you to find sine and cosine and you're given points, all you have to do is just relate the sine and cosine to the points that you're given. Easy peasy lemon squeezy. Oh, but what if it's not the unit circle? Well, let's see what we got. This next one, we don't have the unit circle. The radius is 3. How do I know that? Well, if this point goes over to 3, 0, that means the radius is 3. Don't overthink it. And when the radius is 3, that means my x value is now radius cos theta, and my y value is radius sine theta. Okay, that's my x, that's my y. I'm also given this point down here that I care about where theta travels all the way over here. And so the point that I have is negative 1.1, negative 2.791. So I kind of wish I made this a calculator problem, but I'll use Siri for it because the numbers aren't miserable. It's not like I need to do like the sine of a number or anything wacky like that. My job is to find sine theta. Well, I know from this information over here, two things. I know r cos theta equals x, which means if I divide both sides by r, cos theta equals x over r, just kind of like what we saw in that second or third slide when we began this video. Similarly, and this is what matters here, is that my sine theta is going to be r sine theta equals my y. And if I'm being asked to find sine theta, I'm going to calculate whatever my y is over my r. So sine theta is whatever my y is, which is negative 2.791 over r, which is 3. So negative 2.791 divided by 3.
The answer is approximately negative 0.9303.
9303. So we'll leave that as that. Okay. So probably should have used a calculator, but it's too late now. Cosine is found by doing x over r. So cosine theta is my x value, which is negative 1.1 divided by 3. Negative 1.1 divided by 3.
The answer is approximately negative 0.3666.
Oof, I don't like that. I don't like that. But thankfully for rounding, we don't have to be in fear. Okay, so there's my cos theta. And tan theta is basically the same thing as u divided by u. So negative 0.930 divided by negative 0.967. So negative 0.930 divided by negative 0.367. It's going to be positive.
It's approximately 2.534.
2.534. I like it. I like it. I like it a lot. All right, now we are being asked to find the ratio of each expression. Now, what I'm going to do is I'm going to use that unit circle that we so eloquently did a little while back. I'm going to try to draw that. Holy cow, that looks awful. I'm keeping it. I'm keeping it. All right. And what we're going to do is we're going to label the points based off the angle measurements that I give you. Now, reminder that cos theta is our x value. Sine theta is our y value. So when we look at these, we are thinking, oh, y thoughts, oh, x thoughts, blah, 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 blah. Now, 3 pi over 4. If you remember, here was 0, here was pi. No, it wasn't. That's half a pi. Here was pi. And here was 3 pi over 2. 3 pi over 4 is literally that center spot right there. Okay, 3 pi over 4 was that center spot right there. That gave us a point of root 2 over 2, and root 2 over 2 because that's how the center spots work. In this case, the x value is negative because we're in quadrant 2. I am asking you to find the sine of 3 pi over 4, which means I care about the y value. So the sine of 3 pi over 4 is the y value created by that angle, which gives us the y coordinate root 2 over 2. All right, on to the next one. Cosine of 3 pi over 2. 3 pi over 2 is a little bit after pi, and if you remember, that 3 pi over 2 is actually right here. There it is. So right there. So that point right there is actually the point 0, negative 1. I want the cosine of it, which is the x value. So the cosine of 3 pi over 2 is the x coordinate of 0, negative 1, which is 0. How about that? Catch me outside. How about that? Remember her? Bad baby. All right, sine of 11 pi over 6. That is just before 2 pi. And if you remember, there's 3 dots here. That's the third dot. Okay? Whenever you are coming up with your numbers, when I'm thinking about this, I always think when you start from the x-axis, your x value is going to be that root 3 over 2. And then your y value is going to be the opposite number, which is 1 in this case. Now, since this is quadrant 4, y is negative. I'm asking you to find the sine of 11 pi over 6, which means I need the y value, which ends up being negative 1/2. Okay? Last but not least, cos 4 pi over 3. I'll use black. 4 pi over 3 is in between here and here, and that would be the third dot of this guy. Okay, now the third dot of this guy, if we're thinking x values, that's root 3 over 2, root 2 over 2. That is root 1 over 2, so 1 over 2. And then the other one is root 3 over 2. X and y are both negative. So cosine wants you to find the x value, and the x value is negative 1/2 in this case. All right, so that's how you use the unit circle to come up with values or ratios and stuff like that if you're given a bunch of ratios, which I am. All right, the measure of angle COD is 2 pi over 3 radians. So you are 2 pi over 3, which brings you to the first dot of the 3 dots there. Okay, so C is going to be the first dot. Find the coordinates of C. Here's issue number 1. The coordinates of C are not as simple as me saying, oh, well, this is a unit circle. It is a unit circle, but the radius is now 4. So I have to treat this as r cos theta, r sine theta. Now, if this was the unit circle, since that is the first dot of 3, that gives me negative 1/2 regular root 3 over 2. Negative positive because it's the second quadrant. However, that's not exactly what I'm doing here. If this was the unit circle, cos theta would be negative 1/2, and sine theta would be root 3 over 2. My r here is 4. So I'm going to do 4 times negative 1/2 r, which is 4 again, times root 3 over 2. So that gives me negative 2 and 2 root 3 over 2. No, 2 root 3, sorry. 2 root 3. Manageable. Manageable. B is halfway in between A and C. All right, so if B is halfway in between A and C, that gives you the angle 5 pi over 6. You're my third dot. Find the coordinates of B. All right, well, if you're my third dot, that means you are literally the flipped version of that. So root 3 over 2 negative, and then 1/2. However, I need to multiply those guys by 4. So basically, it's very, very, very similar to what we see up here. 4 times negative root 3 over 2, 4 times a half is going to give me negative 2 root 3, 2. Yeah, 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 yeah. Let B be the coordinate negative 5 root 2 and regular 5 root 2. Find the measure of an angle rotated counterclockwise from the positive x-axis to B. All right. Okay. So obviously, we don't have a unit circle because what this is supposed to be is, first things first, points are supposed to be something over 2. So I have an idea. Let me take this point and multiply this by 2 over 2. So I have negative, so if I multiply u by 2 over 2 and I multiply u by 2 over 2, that looks a little bit more familiar. Okay, so that would be negative 10 root 2 over 2, and u would be regular 10 root 2 over 2. Now, since this isn't the unit circle, I'm comparing this to r cos theta and your r sine theta. Okay? So, what basically this is telling me right here that and let's focus on the sign first because the negative might be a bit confusing and you might look at this and be like, whoa, 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 what did you just do? Root 2 over 2, I know what that is. I've seen root 2 over 2 all over the unit circle. So if I just focused on the fact that sine theta is root 2 over 2, that leaves me with a radius of 10. So similarly over here, since this is negative, I can't have a negative radius. So I'll just pretend that the radius is 10 and the cosine is negative root 2 over 2. So I don't have, I'm not asking you to find the radius, but the radius is 10. However, this is now saying cos theta is root 2 over 2, okay, in its negative form, and sine theta is root 2 over 2. So when that happens, that point, and of course this is not drawn to scale, but that point is that direct midpoint between these two guys. So I have 3 dots, B is the middle dot, which makes this 3 pi over 4. So you are 3 pi over 4. What is the distance from 0 to B? That's my radius. My radius is 10. Figured it out already. What is the distance from A to B if the distance is vertical? Okay, so you are literally on top of the other. Okay, so if you are a y value, right, if the distance here is a y value, then you are root 2 over 2. If this is the same exact guy as that, then you are also a value of root 2 over 2. And so I have root 2 over 2 plus root 2 over 2, which is root 2 times 2 over 2, which is root 2. Did you catch that? Very exciting. Very exciting. Very exciting stuff. I hate this problem. Oh boy, I hate this problem. But I've seen this problem all over like AP classroom and stuff like that. So I'm assuming it might show up somewhere. I don't know. Who knows? We're going to do it. We are given an angle theta in standard position as shown in the figure below. So boom, here's my theta. The function g is given by g of a equals sine a. So this is a sine value. For the angle alpha not shown, theta is smaller than alpha, and alpha is in between theta and 2 pi. So here's 2 pi. Here's theta. Alpha is somewhere over here. Okay? Alpha is that area over here. I don't know exactly what it is, but it's that area over there. I need to figure out what happens if I plug in alpha and theta. So let's view this from graphing the sine function point of view. I care about the sine function from 0 to 2 pi. Sine starts at 0, 0, peaks out at 1, bottoms out at -1. It hits the x-axis again at regular pi. It repeats itself at 2 pi, which means it peaks out at half a pi, and it bottoms out at 3 pi over 2. All right, so let me attempt to draw this out, which I'm always bad at. Let me attempt to draw this out, which I'm always bad at. Not too bad if I say so myself. Now, theta is basically anything from 0 all the way and beyond 3 pi over 2. So theta could be anything from here to like here. Could be theta. So this new guy, alpha, is going to be between here and here. So whatever I plug in for theta, okay, I could plug in, well, theta is right here. So if I plug in theta, I get some number. If I plug in theta, I get like negative something. Okay, so G of theta is like negative like 0.8 or something. Whatever I plug in for alpha, it's going to be to the right of it, which means it's going to be bigger than whatever I plug in for theta, no matter what. So G of alpha is going to be greater than G of theta because anything to the right of theta, no matter what, is going to be higher. So I hope I explained it well. I feel like I didn't, but I don't know. It's just a weird problem. But I've seen, like, there's 3 problems on AP Classroom like this. Like when you, as a teacher, when you assign homeworks, there's 3 that look just like this and the other 3 don't. So like they clearly AP Classroom likes this type of problem. So I don't know. Will it show up on an exam? Who knows? But don't be surprised if it don't. All right. F of x equals cos x. Let's just draw it out. F of x equals regular old cosine x. Okay. Cosine starts at 1. Okay. Hits at half a pi, bottoms out at pi, comes back up, hits again at 3 pi over 2, and repeats itself at 2 pi. Okay? So cosine looks like. Gross. Where is f of x, cos x, concave up on the interval 0 to pi? Concave up look like this. So this happens here. So this is concave down. Then the switch of concavity happens right at pi over 2. Concave up, concave up, concave up. And then the change of concavity happens at 3 pi over 2. Now, at pi over 2 and 3 pi over 2, it's neither concave up nor concave down. So we will say that this is concave up on pi over 2 to 3 pi over 2. When does f of x cos x equal 1? I'm not given an interval. This is a periodic function, which means it hits 1 at 0. It hits 1 at 2 pi. So it'll hit 1 at 4 pi and 6 pi. And if I go backwards, negative 2 pi. So basically, I can word it out like this. Basically, every 2 pi is when it hits 1. Okay, so we will say 2k, right? 2k pi, where k is an integer. Okay, so if I plug in 0, I get 0, which is an answer. if I plug in, and by the way, I should say x equals, make it look better. If I plug in 1, 2 times 1 is 2, 2 pi is another answer. Okay, if I plug in 2, 2 times 2 is 4, 4 pi is another answer. This will work. If I plug in -1, I get -2 pi. That'll work. Boom. Is f of x an even function? Cosine x is an even function, and here's why. 2 reasons. It starts up here, looks like this. It has reason number 1, reflectional symmetry over the y-axis. Whatever happens on the right side of the y-axis, the exact mirror image happens on the left side. It has reflectional symmetry. The other reason why is if I were to plug in f of x, or rather plug in negative x, I would get f of x. Okay, so yes, for the 2 reasons that even functions are even functions. Reflectional symmetry over the x-axis, and also because f of negative x, if I were to plug in negative x, I would get the same exact value as if I were to plug in regular x. Like if I were to plug in 2 pi, I get 1. If I were to plug in -2 pi, I get 1. Okay, and the same thing will always happen left and right. So yes, f of x cosine x is an even function. Let's take a look at sine theta. So we kind of looked at sine. Let's draw it again because it's good for you, even though I'm the one drawing it. Starts at 0, 0, peaks out at 1, bottoms out at -1. It repeats itself every 2 pi times. Okay, so it's going to go up here at half a pi. It's going to peak out at regular pi. It's going to hit the x-axis at 3 pi over 2. It's going to bottom out at 2 pi. It repeats the process. Okay, so starts at 0, 0, peak, hit, bottom, hit, repeat. Okay. Where is the rate of change of g of theta decreasing on 0, 4 pi? It's making me think a little bit. First off, rate of change decreasing. What does that mean? Concave down. Rate of change decreasing means concave down. This is going to be concave down here from 0 to pi over just regular pi, regular pi, regular pi, regular pi, regular pi. Now that is when it's from 0 to 2 pi. It's now concave up. But when it repeats itself from 2 pi to 3 pi, it's going to be concave down again. So we must include those, 2 pi to 3 pi. Don't include them because they're neither concave up nor concave down because those are inflection points. What did I just say? Inflection points? I did just say inflection points. You're an inflection point. You're an inflection point. You're an inflection point. So it looks like inflection points happen at 0 and pi and 2 pi. Inflection points are going to be the x values that happen at every k pi, where k is an integer. There you go. Now I can spell. That makes sense. 1 pi, yup. 2 pi, yup. 3 pi, yup. 0 pi, 0, yup. -1 pi, yup. Pumpkin pie? just, What is the period of g theta? Come on. I think we know that by now. All right. Oh, this is not a calculator problem. Okay, no calculators yet. Let h of x equal sine x and j of x equals cos x. Where on 0 to pi do h of x and j of x have the same concavity? So let me move my face over here because I'm going to need to draw both of these guys on the same coordinate plane. This should be a lot of fun. All right. Obviously, we know the magic numbers. We have pi. We have 2 pi. We also know the magic numbers of 1 and -1. Okay. Sine x, I'm going to let u be red. Sine x starts at 0, 0, peaks out, hits the x-axis again, bottoms out, and then repeats. I'm going to let cosine equal blue. Cosine starts here, works its way down, bottoms out at -1, crosses, and then repeats. Okay. This is going to be interesting. I want the same concavity. All right. Red is concave down between 0 and pi and concave up between pi and 2 pi. Blue is concave down between 0 and half a pi, and then between half a pi and 3 pi over 2 is concave up, and then concave down again for the rest. So both of these are concave down. So I'll say that. I'll be specific. Concave down on the interval 0 and pi over 2. And both of these are concave up on the interval pi to 3 pi over 2. Gross. Where is h of x, red, greater than j of x? I can't do that without a calculator. I can't do that without a calculator. So is that... I wonder if that I should have started calculator time there. I mean, I created these problems. I should have just started calculator time there. So this is what I'm going to do. I'm going to take a little side. Let's look at this problem. This is a calculator problem. You can't do this without. There's no way. This is a calculator problem. So it's basically going to happen where, what do I want? I want where red is greater than blue. So it happens between the intersection right here and the intersection right there. So what I need to do is I need to find out those two intersections, and I'll answer it that way. Right. Y equals, well, first off, let's make sure your mode is set to radians. It should be, it is. Y equals sine x and cos x, like that. I'm going to go to zoom and make it zoom trig, because then it makes it all triggy. So there's my guys. I wanted to find out this intersection point right here and this intersection point right there, because the one that I wanted was greater at those moments. So I need that intersection point. So let's go to calc, second trace, click 5 intersect, and it's going to intersect forever. So I'm going to hit enter. I'm going to make sure that I give it an interval. Otherwise, it's going to fall apart on me. And by giving it an interval, it gives me one intersection point of 0.7053, blah, 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 blah. So the x value is going to be 0.7, what is that, 85 or 05? That's an 8, 785. Okay? Yeah. All right, so we need to find the other intersection. Second, calc, intersect. And let's make sure we go over here. Let's make sure we go over here and give it an interval, because we have a bunch of intersection points. Otherwise, it's not going to know what we want. So there's the interval. Okay, so everything in between that. And that guy gives me 3.9269. So 3.927 is going to be my interval. So let's go back and write that out. All right, so when we did that, this guy right here ended up being 0.785 is what I wrote down over here. That guy ended up being 0.3927. No, 3.927. So definitely you need a calculator for that one. Not as simple as one would hope. Although there's other ways that you can do that, but we're not there yet. All right, I digress. C. Where on the interval 0 to pi is h equal to 0.75? So I'm dealing with sine, and I need to graph 0.75 and see where my sine curve is going to cross 0.75. So I need an intersection there and an intersection there. So let's see what happens. All right, so now we are being asked where h of x is 0.75. So the h of x was the sine, so let's pretend that the cosine's not there, and we can do that by going to the equal sign, and now it's gone. Okay, so only sine shows up. I care when it's equal to 0.75 on the interval 0 to pi. So what I'm going to do is I'm going to graph 0.75. Let's see. So here's 0. Okay, here's pi. Here's 2 pi. It looks like it hits twice. So I need to find both of those intersection points, both of those x values. So I need the intersect. Second, calc 5. And I'm going to make sure I'm very clear that I choose the interval between that guy and that guy so that it gives me what I want. So that actually gave me the one I didn't want. That gave me the second one, 2.293. So that's going to be my second one. Don't know why it did that. 2.294. So that's the second one. I'm a little nervous, but we'll see what happens. Second, calc. Intersect again. Let's move to the left of it. Enter. Move to the right, maybe not too much. Enter, enter. And it worked at that time. 0.848. 0.848. So that's my other guy. Okay, that happened at two spots. 0.848 and 2.294. Find the average rate of change of j of x. So now we're on cos. J of x on the interval 1/4 of a pi and 3.75 pi. All right, so rate of change, average rate of change, is f of b minus f of a over b minus a. So what I'm going to need to type out in my calculator is, what am I doing? J, which is cos of, remember, you're my a, you're my b, cos of 3.75 pi minus cos of 0.25 pi all over 3.75 pi minus 0.25 pi. Well, you're not going to get a pleasant answer. Or are we? All right, so this is how I'm going to handle this one. I'm just going to type this all in one foul swoop that you saw me write down a minute ago. Cosine and parentheses, of course. Don't forget your parentheses when you have a numerator. 3.75. Pi is second caret thingy. Close the parentheses. Minus cosine again of 0.25 pi. Close it, close it. Now I'm going to divide parentheses 3.75 pi, so 3.75 pi minus 0.25 pi. second thing. Close it and see what terrible number that I get. Well, 0. Now I get 0. And if you're like, that's not 0, e to the negative 14 is 0. So let's write that out, and let's go back to our Google side and see if we can figure out why. We got 0. Why? Well, here's the thing. Cosine look like this. Cosine look like this. And we're going all the way out to 4 pi. So let's go all the way out to 4 pi. All right, so cosine starts up here. Okay, there's 2 pi. And there's 4 pi. Okay, a quarter of a pi after my initial beginning, I'm like right here. A quarter pi before 4 pi, I'm at the same exact level. The same exact level. Which means if I'm like whatever number that is, which is point something, 0.9, I end up at 0.9 after who cares of amount of time. I haven't changed anything. I haven't changed at all. The average rate of change of a horizontal line is nothing. Isn't that fun? Isn't that weird? Isn't that something else? I don't know. I think it's nice. It's not like I did that on purpose. I don't know. Thank you guys for watching. A couple more of these, and then we'll be done AP Pre-Calculus. So I appreciate everybody liking and all the comments. So please don't stop that anytime soon. It's fun to see my YouTube grow just a little bit. So keep that going, please. Thank you so much. I love you all. Thanks for watching. Bye.